Yes, student. In last video, I defined alternating current, alternating voltage, and how to represent them. So, from definition of alternating current, we get that I equal to I zero sine omega t कह लो या I zero sine 2 pi upon t into t. I is the value of current at time t, so which keep on changing. Here, one thing more I forgot to write there. 1 upon t equal to frequency of AC. I write it by F. So we can write I equal to I0 sine 2 pi f t. Actually, frequency in books they write nu. तो न्यू फ्रीक्वेंसी ऑफ वेव से कंफ्यूज ना हो हम, तो दैट्स व्हाई आई राइट एफ. तो दैट आई कीप ऑन चेंजिंग periodically with time, and the frequency of ordinary current we are using in our home in India it is 50 hertz. What does it mean? Keeping conductor here and current goes 50 times this way and 50 times this way in 1 second. So very frequently it keep on changing. Then how to measure and what value we can measure? The question arises, which value I or I0, by in circuit neither I nor I0 remain there forever, keep on changing very frequently, then which values to be measured? So before telling all things, I come here. You may think that we may take average value. If we find average value of alternating current for one complete cycle, then we proceed as follows. Your way of thinking may be different from me, your expression may be different, but this is my natural way of telling you things. As follows. कैसे भाई? You know I equal to Q by T होता है और Q equal to IT. So here average current for one cycle will be I dt is the charge flown in time dt. We want total charge flown in time one cycle. So it is the charge flown in one cycle divided by integration dt means time. क्योंकि I equal to Q by T. So 0 to T. You will write here integration 0 T I0 sine omega T dt upon integration dt तो T हो जाएगा. अब it is T. तो इंटीग्रेशन come out I0 upon T तो outside. 0 to T sine omega T dt. Bio student may feel some difficulty, but you can do this thing easily. You keep on learning again and again. So this average value for one cycle, I bar, it is for one cycle. I0 upon T, or you know, I have told you, integration sine AX is equal to 1 upon A or minus sine A cos AX. This is the formula for differential here. So it comes out to be minus 1 upon omega or into cos omega t 0 to t. It is minus I0 upon t into omega or cos omega, in place omega we write here t. Actually in our exam question are asked based on this. That's why I am telling. Putting t equal to t minus I0 upon t omega or sin 2 pi, cos 2 pi minus cos 0. Cos 2 pi 1, cos 0 1. Minus I0 upon t into omega and it will be 1 minus 1, 0. So average value of alternating current of the semi-pole voltage is 0. So we can't measure AC. So average value of alternating current, average value of alternating current, average value, sorry छूट गया, average value of alternating या AC current लिखूँ, AC current and AC voltage cannot be measured. Graphically, you also see here for one cycle, positive or positive, as many values are positive, we sum them the same value negative, so their average 0. You may be asked here also, in exams I have seen questions, find the value of current for positive half cycle. ये जो पॉजिटिव हाफ रखी थी इसकी एवरेज वैल्यू क्या होगी? For that you can proceed the same way. Average value of AC for first half cycle, first half cycle, second half तो negative होगा, तो again you can get half average 0 to t by 2 I dt upon 0 to t dt, and this तो t by 2 t by 2 sorry t by 2 dt. So it is I0 upon t by 2 and integration 0 to t by 2 sin omega t dt, because ना I बराबर this I equal to I0 sin omega t. Please practice this. In one exam the limit was not this, limit was 0 to omega by 2. Omega 2 pi upon t, तो t की जब t by 2, तो t by 2, what was the limit? ये कुछ और था, अभी मैं वो लिमिट बता देते हैं वो सही. तो then again it is minus I0 to I0 upon omega, sorry t, और into this minus sign मैं यहाँ लिखता हूँ 1 upon omega और cos omega t 0 to t by 2. So minus this minus 2 I0 upon t into omega 2 pi by omega into 2 pi, or it is minus here also, and it is cos 2 pi upon t into t by 2. So how much it will come out? That I half plus half cycle equal to minus 2I0 upon 2 pi, or it is cos pi by 2. But it will be, अगर we put here t, तो t by 2 cos pi, cos 180, cos pi minus cos 0. Upper limit minus lower limit. So it will be minus 2I0 upon 2 pi, or minus 1 or minus 1. So it is left here I positive half bar is equal to 2I0 upon pi. These two cancel, minus cancel. Similarly, this question has been asked one in exam. Okay, what is the half average value of half cycle? Positive half, 4 negative minus half, it will be minus 2I0 upon pi, and therefore for complete cycle it is 0. So question arises, what do we measure and what is the principle of measurement? The current drawn from battery you measure in class or practical lab by ammeter, voltmeter, and I have told you while teaching magnetic current, the moving coil galvanometer. So that moving coil galvanometer works on the principle that when current carrying loop is placed in magnetic field, that experiences a torque, and that torque is equal to vector quantity m cross b, or direction of m also depend on current, you know, if clockwise, so it is into anti-clockwise outside. So if we use that galvanometer, that galvanometer can be called the ammeter voltmeter. So that will not give any deflection because frequency is very high. So galvanometer coil will not be able to get deflection. And that measurement of direct current is using magnetic effect of current. So how many effects of current you know? There are 3 effects of current. Number 1, magnetic effect of current. Chemical effect. You know what is chemical effect? बच्चे चुप हो जाते हैं. Electrolysis. When we pass electric current through the aqueous solution of certain ionic compound, the constant element get deposited on the electrodes. And number 3, heating effect of current. Heating effect. The magnetic effect and chemical effect both depend on direction of current. Here cathode and anode are there. If you keep on changing the polarity, then no electrolyte takes place. Heating effect, heat produced by conductor I square RT, I negative or positive square positive. So alternating current is measured by using heating effect of current. So what we measure by the principle of this, So I write here AC current. Sorry. The magnetic effect of current and chemical effect of current, जिसको कहते हैं इलेक्ट्रोलाइसिस. You have learned in chemistry Faraday's laws of electrolysis. Both are direction dependent. Direction dependent. So these effects cannot be used to measure AC current and AC voltage. So ordinary current cannot be measured by using chemical effect and magnetic effect. So heating effect is used. Heating effect of current is independent of direction, as H equal to I square RT. So we use this effect to measure AC current. We use this effect to measure AC current and voltage. A question arises, what value is measured? If we find the square values of AC current for one cycle, positive and this positive, these are square values, I square, for first half cycle or next half cycle, if we find the average of these, we will get something. So in measurement of AC, an AC ammeter or voltmeter measures the root mean square value of current of AC current and AC voltage. And remember, they use heating effect of current. In coming video, I will be telling the definition of AC and its relation with peak value. But here I want to explain you something. It is a symbol of AC source. In India, we use frequency 50 Hz. In US and UK, if they use 60 Hz, F, I equal to I0 sine 2 pi Ft. This F is 50 Hz, omega 340. Then how the current flows? This is very important to listen to me. Ordinary current and voltage both are vector. but we never mark the direction in circuit here, a current going this way. Why? Because keep on changing very frequently. Then how we told you the drift velocity of electron when current is flowing, that is a millimeter order. So electron cannot go 50 times this way, 50 times this way here. Then what happens? Basically, when alternating current flows, electrons are present everywhere in circuit. Electrons are present everywhere in circuit. They start oscillating only about their mean position. So whenever we say current has gone, current has come, so it comes the frequency, not the current. In our circuit, electrons start oscillating and net movement of charge make current. So remember that this frequency, 50 Hz, this is the frequency of oscillation of electron in the circuit. I will take definition of root mean square value another in next video.